Hello, everybody. Brad Hoyt here, and I'm here today with Casey Baker. We'd both like to welcome you all to the SmartCAM Quick Tips webinar. Today, we are focusing on machining using a solid model in SmartCAM, and that can be done in our milling applications, all of them, as well, or excuse me, the advanced level milling applications, as well as advanced turning. A little bit about how this will work. Your microphones will be muted, so if you have questions, click on the text bubble icon at the top of your screen, type in your question, and time permitting, we will answer those questions at the end of the webinar. There's also a full screen icon at the bottom right area of your screen, which may help viewing Casey's screen a little bit easier. You don't have to worry about taking notes. This is all being recorded, and we will be emailing you a link to that recording if you'd like to refer to it later. There will be another webinar in September, so keep your eye out for an invitation. And now a little bit about today's topic, milling from solids. One of the comments we hear regularly from even very experienced customers is, I know how to get the job done, but I'm not sure if I'm doing it using the ideal processes. And very often they're right. There is often a better way available to them that they just have not been exposed to. Getting solids CAD data is very easy now with the popularity of SolidWorks, Inventor, and other CAD systems. But we're discovering that a lot of our customers are new to working with those solid models in SmartCAM. So there's two basic strategies when you're machining from a solid model in SmartCAM. One, machining from the wireframe data, or two, machining from the solids data. Machining from the wireframe data can be done using production milling, advanced milling, FreeForm machining, or advanced turning. Machining from solids can only be done using our advanced products, advanced milling, FreeForm machining, or advanced turning. Our internal testing has shown around a 75% savings in time when you machine from solids as opposed to wireframe. So, in addition to showing both of these strategies today, Casey will be going over how to properly prepare geometry when working with the older format IGES, which is still pretty popular, as well as a couple of tips for orienting and positioning your parts in SmartCAM. So many of you already know Casey. He's our SmartCAM training manager, has over 25 years experience training people in SmartCAM. And with that, take it away, Casey.
Thanks, Brad. So as Brad said, we're going to be looking at creating toolpath from solids. I'll be giving you some recommendations on importing, validating, and healing solids, and then how to orient the solid and create wireframe geometry. I'll use the wireframe pocket process to machine the solid, then use the solid pocket process to machine the solid. And I'll give you some tips and techniques that make working with solids easier. We do recommend ACES, SAT files, or STEP files, or the native CAD such as SolidWorks or Inventor. However, we've found there's many IGES models in use today. We'll start with IGES. So I'll bring in an IGES file. And it should be coming in here. There's the file, hit F12 ISO. Now if I hit F7 element data and click on one of these surfaces, notice a couple things. First, the element is a spline surface. That's an IGES type surface. Also notice that it's not a member of the solid. If I close out of here and double click on it, on one of the surfaces, I won't get any of the other because they are not related. They don't see surfaces that are right next to each other. And likewise, the group icons will only pick single surfaces. So the first thing I'll do is group everything, group all, and I'll go to Edit, Surface Edit, Validate. I'll turn off healing, check level to medium, and I'll hit go. This will bring up a report that shows the state of the model from an ACES point of view. It will report surfaces it considers not good. However, it is possible the surfaces will be okay in SmartCAM.
Casey, quick question. You've been training quite a few customers over the years. Are you finding that our customers are aware of this report? Is this something that everybody's referring to?
Yeah, I don't see too many people using this report. And the next thing is I'm going to be showing you
Oh,
the heel and the stitch.
okay.
So with that, we'll reset that and close. We'll go to what we're going to do now is heal the model. So I'll turn on healing and I'll hit go. It does bring up the report again. Now if I hit F7, notice that the surface type is a plane, and that's the more desirable surface type. Spline surfaces have a lot of data in them. Plane surfaces you'll see down here is a cylinder now. That was before a spline surface. But if I turn on the group, if I double click it, it still is not a member of a solid. And what we're looking here is the element type we're looking for here is a plane or a cylinder or a torus. So the next thing we'll do is we'll stitch the model. So edit, surface edit, stitch. Notice down here 59 surfaces in the model, 0 solids. So when I hit go, notice now there's 1 solid. And if I hit F7 element data, you can see down here now it is a member of a solid, and it is a plane. And you can see here there's a cylinder type surface, plane. Now also the surface group icons will work as we'd like them to. This is tangent, and this is adjacent. I want to point out that healing is not recommended if it is not needed.
Question, why would it not be recommended? Why would you just not heal everything?
Healing will slightly change or can slightly change the model. So you run the risk of changing it to how it was not supposed to be. It is a very slight change, where 2 surfaces come together. It might move one of them ever so slightly.
So it modifies the geometry. I see. Okay.
Yes, slightly.
So
what you're looking for is the element type being a plane, cylinder, cone, and so on, and also associated with a solid. If you don't see that, then you can go to File, Open, and turn healing on right here in the Open panel.
okay. So is that it for working with the IGES format?
Yes. What you've seen so far, it just applies to IGES files. IGES files have been around for decades, and the newer surface type files are more desirable.
Got it.
So what I'm going to show you now is orienting the model. Most often, a model will come in and it only needs to be rotated 90 degrees, one direction or the other. In this case, we want to rotate it on the x-axis down so it's flat in the XY plane. Many of you know the right-hand rule. I'll go to rotate here, 3D. The right-hand rule is if you put your right-hand thumb in the direction of the vector you want to rotate around, your fingers will point in the positive direction. So I can see I want this model to rotate minus 90, but I wanted to show you something I often do so I don't have to figure out whether I want to go plus 90 or minus 90. I just have 90 and I'll hit go. If it goes the wrong way, as it just did, I'll hit go 2 more times. Now, a lot of people would hit undo, change it to minus 90 and hit go. All you have to do is hit go 2 more times. Now, a few times we get a model that is not 90 degrees in one direction or the other. So I want to show you a file that has multiple offsets. So I'm going to hit F9 top view, and you can see it's twisted just a little bit in the top view. Here's F10 front view, and it's tilted a little bit there, and F11 side view, and you can see it's still tilted. I could figure out all three of those angles and rotate the part, but I want to show you a quick way to get this part into the XY plane. I will define a plane on this part using 3 points, origin point, and remember when the arrow changes to a plus, that means SmartCAM has found an existing element in the database. So my second point right there, and my third point for the work plane, and you can see a work plane indicator right here. Notice the big numbers, 26,000. This part obviously is a metric file, and the part is way out there. So I'm going to just accept the default user one plane name, and I'll hit accept. Now I want to property change to change the work plane on the elements you're looking at to the user one work plane. So I go to work plane, user one, accept, and then I go to transform move, destination plane, XY. And I'll hit F12 ISO view, and so there's the part flat in the XY right where we want it. So we'll go back to that other pocket file. Now, what I'm going to use now is create from solid and boundary. I'm going to use boundary and slice. We'll go to create from solid slice. Just to note, we do not recommend using extract to create wireframe.
Casey, I have got. I'm sure my customers are using extract. Why should they not do that?
The result from extract is polylines, and the result from boundary and slice are lines and arcs flat in the plane, the active work plane. So
okay.
Working with lines and arcs is more desirable than polylines. So I'm in slice right now. I'm being prompted for surface on the solid. I'll click on this plane. Z level, it's asking for a Z level to slice the part at. I can click on and snap to existing Z levels. So I'm going to click right here, and I can see that is minus 0.5. And I'll click right here, and I can see that's minus 0.65. So if I wanted to pick a point on this vertical face, I move the cursor just onto that face midpoint between the two surfaces I just clicked on. And it's as if there was a ray shooting through the surface there, and it will find that Z level. So I click there, I can see it's minus 0.563. I'm just going to type in a minus 0.55 and hit go. Now you can see that the slice is all the way around the part, inside and out. And that's just a wireframe elements, lines and arcs, that you can use for creating finish pass or a chamfer pass. So I'm going to undo this. And I just lost my. Okay, and I can also slice a group of elements. So I'm going to click on a few of these surfaces here. And I'll click on group slice, and you can see it's the same Z level. And it gave me a slice, or excuse me, lines and arcs around the surfaces that I put into the group. So I'm going to undo out of that and clear out the group. Now we'll go to create some boundaries. So my first one is going to be a perimeter around the top of the pocket. So I can click on this button right here and it'll bring up the submenu that slice is a part of, and now I want to go to boundary. Click on, surface. So I clicked on that surface and it found the outer boundary. I want the inner, so I hit find next and it found that. I want to be on CAD layer 4 and I'll hit create. So it just created a boundary on layer 4 around that pocket. Now I want to create boundaries around all of these islands. So I'm going to do that on layer 6. I'm going to turn profile top off. I'll group the islands. Rotate this around to get the 2 right here. Prof top is off, and create from group. I need to change this. Create. The 2 options here are create from surface or group. I'm creating these from group and hit create all. So there are the boundaries around the islands. Now it used to be that to define an island, you needed the profile at the bottom of the island and prof top set to the top of the island. Now all you need to do is put the profile at the top with prof top turned off, and it'll work the same way. Now I've got to move this profile down to the bottom. So I want to show you a little bit about filters. This icon right here is turn filters on and off, and this is setting the filters. So I'll go into here first. You can see this first one in the upper left is point, then hole, then line, then arc. So that is going to turn on or off what element types I can pick. And you can see that the one in the lower left is surface, and I have that turned off. So by toggling the filter icon on and off, it will allow me to pick or not be able to pick surfaces. In this case, I don't want to pick the surface behind it. I want the profile that is the pocket. So my surface icon filter is on, and it didn't, as you can see, it didn't get the surface. It got the profile I wanted to. Now I want to move that down. A lot of times I could possibly use transform move, but in this case I use property change layer, because in property change I can set prof top and level at the same time. So I'll set prof top at 0 minus 0.75 and accept, and you can see it move down to the bottom of the pocket. So now we want to go ahead and machine that pocket. I will group the islands. Switch on, go to CAM, and step 10 is active. I'll go to process, rough, pocket. I'm going to set my boundary, or my path type to part offset. The boundary will be that element right there. It's any one of those elements. I'm going to change my ramp to 5 degrees. My first pass to minus 0.1875. At 0.1875, and I'll go check that rough only on smoothing and avoid grouped islands. Accept. And I'll hit go. So there is the roughing of that pocket using wireframe geometry that we got from a solid model. I'll go into verify. Double check my work setup is set to 7. It is. And I'll turn material on and hit go. and you can see it's machining in the pockets. I think we've got one more Z level. And there it is. So now we've just finished roughing out this pocket using wireframe geometry that we got from a solid. Now I'm going to read the file in again. And we're going to do the same thing, but with solid modeling. So I'm going to group the surfaces that we want to machine. And here I'm using adjacent. And we'll go to process, solid machine pocket. Again, some of the same numbers, 5-degree ramp, finish allowance. I'll make my end minus 0.75. Depth of cut 0.1875 and hit go. So there's the roughing of the same pocket using surfaces instead of wireframe. So it's quite a bit quicker. We'll go ahead and do a quick verify. And there you can see the same part, but this time our input was the solid model. So that is it for creating toolpath with solid models.
Nice work, Casey. You're getting pretty good at this webinar thing, man. Pretty clear why using solid machining is so much easier than working with the wireframe stuff. As I mentioned, we've done some testing here, and things that take 12 minutes with wireframe take 3 minutes with the solid machining. So let's take a look. We have a little bit of time left to see if we have any questions. Casey, question. A user says, when I use the adjacent selection method, it picks the whole model. What am I doing wrong?
Well, if you noticed, I picked, when I grouped that part, or grouped those surfaces, I'll clear it out. I used group arrow to group the first one, and then I used adjacent to pick the inside. And what adjacent will do is it will go outward. It will pick any adjacent surface out to any that are already in the group. So I purposely picked this one, the outer top one first, and then the inner one. If I had just picked adjacent and picked any surface, it would have gotten everything. Now also imagine if there were a through hole on this part, adjacent then would have gone through the backside and come out the outside, and it would have gotten everything. But in that case, I would have picked the top surface first, then the cylinder surface that describes the through hole, and then adjacent to get the rest of them. And it would have picked everything in between those two that I picked first.
Got it. Got it. Second question, I can actually answer this question. Is the model available for download? I'd like to try to walk through this exercise myself. And the answer is yeah. If you're interested in doing that, just get a hold of your account manager or Casey, and we'll send it your way. We'll make it available to you. Or international customers, you can contact your reseller, and they'll be happy to get you squared away. And I think that is it for questions. So again, Casey, nice job. Thanks everybody for coming. We're going to be sending you all an email to get your feedback. There'll be a survey. That helps us pick what the next Quick Tips webinar is going to be. It'll also include Casey's contact information. Many of you are aware of our training center at our headquarters here in Springfield, Oregon, but you might not be aware of another training option which has been working great for everybody who's tried it so far. What we're doing is online training, and the way it works is you drive SmartCAM on your computer and you share your screen with Casey, and you use Join Me, which is what we're all watching this webinar from. And Casey directs you through specific training exercises just for you, and we record it we save those recordings in 1 hour blocks and we make them available to you. It works great. So if you're interested in finding out more about training here at our headquarters in Springfield or online training, either contact your account manager or Casey directly, and we'll be happy to help you out. So thanks again, Casey, and thanks to everybody else. Have a great day.